Um, Hello, my name is Janabel. I am pretty new to this space, I guess. So, yeah, my background is more on the math researchy side, but this summer I wanted to explore kind of like the development and thinking about application side layer of the stack. So, yeah, I'm going to be talking about just like a small project that I've started over the summer and recently have like an MVP of, and very happy to like jam on ideas of applications of this. It's not super practical right now. It's actually dealing with the same problems that Vivek was alluding to with folding and folding not being super practical in the browser right now. But yeah, very happy to jam on this stuff afterwards with people. Yeah, okay, so my project's about pod folding. This talk is like kind of just like a raw description of the project. But so what is a pod? A pod is a cryptographic data type that is attested to by some issuing authority. So this like data inside is really just like a key value store. So you can think of it as a JSON. Maybe it has like an entry that says like name and then Janabel and like date of birth, like whatever my birthday is. Just like a bunch of information in a key value store. And then an attestation in this case is just a digital signature of the pod. So in more detail, pod entries are first hashed into field elements so that you can feed them into circuits as leaves of a Merkle tree. And then the signature of the pod that I was referring to is just going to be a signature of the Merkle root of that tree. So basically you have like all the entries, you're hashing them to be like compatible with kind of circuit data types. And then you like bash that up into a Merkle root that can identify what's inside the pod. And yeah, so I'm not going to go into the details of this, but basically, like by creating this Merkle tree, you're allowing a user to selectively prove that certain entries exist inside the pod without revealing all of the entries. So you can imagine maybe a use case of this is like, say I want to go to a bank and apply for a loan. And maybe I have a pod that represents like my valid government ID. And then I have another pod that represents like my credit score. Maybe it's like a bank statement. But I don't want my bank to like know, or I don't want the bank to know like all of the data that's inside. When I'm applying for a loan. So I can basically just like selectively say, okay, yeah, I have like this credit score and then my other transactions are private. And then like, oh yeah, here's like my name and like my birthday or something like this. And like the useful components of my government ID, or maybe not even like any of the components, but basically that I have a valid government ID. Yeah, so in this way you can like prove things while keeping stuff private. Yeah, so an example of a pod is, yeah, let's say like I have a name entry, my name is Janabel, and it's going to be a string type. You have a date of birth, maybe you have like an apartment unit or something, and you have your owner ID. Yeah. So the thing that I am building on top of is basically these two apps built by some people at 0xSpark. So there's this thing called Frog Crypto, which is basically like kind of a game that lets you collect these frog pods. So these frog pods are issued by the Frog Crypto website. They're signed by the Frog Crypto website. And then inside the frog pod, there's all these like key value pairs of like, what's the frog ID? What's like the frog speed? What's like the biome that the frog lives in? It's like all this like fun information about the pod. And then Frog Crypto will sign and issue this pod, and then we'll send that to your zoo pass, which is another kind of application that 0xSpark built, which is essentially like a cryptographic data storage. So it stores your different pods and helps you manage like visualizing the pods. Yeah, okay, so that's kind of what pods are. Now let's talk about the action that we're doing on the pods, which is folding. So what is folding? Folding schemes are a method for efficient, incrementally verifiable computation, which is just a fancy word for saying you're kind of verifiably computing some repeated iteration of a function f. So here's like kind of like a visualization of what that would look like. So essentially you're starting with like some state z naught, and then you have some external witness w naught that you also feed into the function, and then like, yeah, you feed that through the function f, and then you get your next state. And then you can do this many, many times. So folding would let you prove that like you computed this final zn after like n steps as a result of this trace of computation correctly. Yeah, so wi we call these like external witnesses, and then zi you just think of them as like intermediate states. Yeah, so there is a paper called Nova for like, I guess people who are interested in like more of the details, but Yeah, Nova is actually, I think it's like one of the first proving schemes, and there have been a bunch more that are like better in different ways. There's like various trade-offs since then. But yeah, the proof length is something like log f, where f is the size of the kind of circuit representing a function f. And then, yeah, I guess when you're doing this like proof that you did this computation correctly, instead of like proving in the normal ZK circuit, you would like basically have like all of the iterations of f inside. But instead of like doing that whole thing inside of a snark, you're going to like compress the witnesses and then also be able to compress the snark into just like one like f check, if that makes sense. So yeah, your circuit size becomes like the size of f instead of n times f, which would be the naive way of proving that you did this computation correctly. And then yeah, there's like a recursion overhead that's like n times a multi-exponentiation of size f. But yeah, that's just like some details for nerds, I guess. And yeah, so now that we've talked about pods and we've talked about this like overall idea of folding, what is folding pods? So folding, when applied to these like pod cryptographic data types, basically allows us to prove ownership or other information about many pods at once. So in the application that I'm building, it's just ownership. But yeah, so now our external witnesses at each step of the computation are the pods themselves, plus any other like user data that you need. So here we're proving ownership, so you kind of need your application to also like get your ID. So you can say, oh yeah, my ID matches what's inside the pod. So these are the data that's going inside the external witness at each step. And then the intermediate state, you can basically think of as like a counter for how many pods you've folded in already. Yeah, so the function f essentially is like kind of like Boolean check. Is this pod valid and like do I own it? And then if yes, then I'm going to add 1 to this intermediate state. Yeah, so okay, well, okay, I guess it's like really slow in the browser right now. But yeah, I can just like do a quick little demo. But yeah, this is my first time like building something on my own. So it was pretty fun to like learn web dev and like about folding and like compiling things to WASM, and then there's like all these annoying things that come with that. And yeah, okay, so here we're at like this little frog counter site. So this first site is basically going to generate that proof that I have a lot of frog pods. So yeah, now I'm connected to my, ZooPass account. So it can actually access the frog pods I have in my ZooPass folder. And then you can press this button below. It's gonna take a while. It might take like a minute. But yeah, so some things that we're working on right now, or that people are very welcome to work on, are basically getting this faster in the browser. So right now we're using a folding library called Shinobi that XeroXpark and PSE have developed together, and they've been doing like great work and adaptations based on this project that I've been talking to them about. So yeah, they're kind of like building out new things on the library as I'm building this to like get the features that I need. But right now, inside of the Shinobi folding library, like the way that the folding works is taking just a WASM file that represents like instructions on how to generate a witness for your function, or like for your function f that you're wanting to prove. And so it's taking that and then doing the witness generation inside and then doing the rest of the folding, which is like compressing the witnesses. But we're also compiling that, we're compiling that API from Shinobi into WASM as well, like to be able to run it in the browser. So we're getting like a WASM inside a WASM, which we believe is the cause of the blow up. So right now we're working on something where that witness generation is actually happening just like native in browser. So like it's just reading the original like WASM for witness generation, and then Shinobi can take those witnesses and like do the folding on that directly. So yeah, that's one thing we're working on. Oh, okay, the proof. Yay, okay, nice. But like notice how I only have like 4 frogs in my ZooPass, and it took like about a minute. Yeah, the proof steps like start out taking like 7-10 seconds and then goes up to like 40 by the 4th frog. So yeah, very not practical right now. But we created proof nonetheless. Let's download the proof. So it's just gonna be like a serialized binary file. And then yeah, so now I can go to kind of the verifier site. So I've proved, hopefully, that I have a lot of frogs in my zoo pass. And so I'm going to go to like a frog whisperer exchange site. And now I can upload that serialized binary. And, oh, well, can I? Yeah. Okay, and hopefully this works. And now it's trying to verify that proof that was just spit out. Yeah, so the folding thing has already happened. This verification is just like normal like IBC proof verification. But yeah, it's important to note the folding happened on the prover site when you're trying to like prove that you have a lot of frogs. Okay, cool. So it says that I have 4 frogs. This is just my like semaphore ID, so my public identity. And then these are just like other like entries within the pod. Yeah, it's going to ask for my permission to sign it. Okay, and now congrats, you're a frog whisperer, and you have this little like frog whisperer pod that says gotta catch 'em all. Yeah, and then you can press this button and it'll add that pod to ZooPass. Yeah, so the cool thing is that the ZooPass team also built like a ZooPass API, so you can issue pods. You can, as a developer now, just like issue pods to your ZooPass on your own. Yay, okay, so it says pod added. Let's see if it was actually added. It's definitely in there, but I have a lot in there, so you probably can't tell which one was just added. But yeah, just to show what they look like, yeah, there's a lot of frog whisperer pods. Okay, yeah, so that's just like a demo of this fun little app. But yeah, so some kind of like higher level remarks about what's going on. Even though it's not super practical in the browser yet, I've been thinking about like what this would mean in the future once it becomes practical. So in theory, this can kind of turn pods into like a private currency where you can trade